morning, everybody. Mrs. Horn here. Today we're going to take some notes on glaciers. Glaciers move materials of all different sizes. So glaciers are related to erosion. Remember, weathering was breaking down rocks into smaller pieces, and then erosion was moving those pieces. We can erode things with stream water, with wind, and now we're talking about glaciers today. We have about 5 pages of notes to get through. There's not a ton of writing on there, so there's a lot of pictures and diagrams to label. Get your colored pens or your colored pencils ready if that is what you've been using. And again, if I get going too fast, just pause the video so that you can get everything written down. Here we go. Okay, a glacier. A glacier is a large mass of moving ice and snow. Usually we find them at very high altitudes, so meaning high up in mountains, or high latitudes, meaning close to the North Pole. This picture over on the left, this is a picture of a glacier that's in a mountain. It's called a valley alpine glacier because it's in a mountain valley. And this, it kind of looks like just snow. It looks like just snow has fallen there, but actually that is a very thick piece of ice, and as that moves, it will move with gravity, and it will move down the mountain, and it will pick up particles of all sizes. It can pick up boulders, just picking up in the ice and moving it a couple meters or maybe 1,000 feet down the mountain. Examples of valley alpine glaciers. So think of any really large mountain range in the world. The Alps, the Rocky Mountains, which is out west in the United States, the Himalayas, that's where Mount Everest is, it's the tallest mountain, and then the Andes Mountains. We also have what's called a continental glacier. Now, a continental glacier is exactly what it sounds like. It is a glacier that forms over really large areas of land, like a continent. Antarctica, which is down in the South Pole, that is all one big piece of ice, and it's very thick, and that is considered a glacier. Greenland, the country of Greenland, is covered in mostly ice, so we consider that a continental glacier. Okay. Over on the next page, we're going to look at the different parts of a glacier. Now, if we're talking about erosion and what kind of glacier is going to erode things faster, it's going to be the one that's in the mountain. It's going to be the valley glacier. And the ice that is in the center, so if I look down here, here's on the sides, and then ice in the center, that's going to move faster than the ice on the sides, which this totally relates to our stream erosion idea. And when we talked about streams moved slower on the sides and faster in the middle if it was a straight stream. If it was a stream that had a meander or a curve in it, then we had some different rules there. Glaciers create different types of moraine, and moraine is simply a bunch of rock pieces. But depending on where that moraine ends up, we have a different name for it. So any little pieces of rock that end up on the side of the glacier, we call that lateral moraine. Any pieces that end up in the middle of the glacier, we call that medial moraine. And then any pieces that are underneath the ice, that are at the very bottom, we call that ground moraine. So moraine is rock. It's pieces of rock that get picked up and deposited by glaciers. They are of all sizes, so small, medium, large, huge, they could be anything. And then these three definitions here are the three things that we just labeled up on the diagram. So we've got the lateral moraine, which is the unsorted material that's along the walls. We've got the medial moraine, which is the unsorted rock that's in the middle of the glacier, sometimes where two glaciers come together. And then the ground moraine is the unsorted rock and sediment that's underneath the ice, kind of trapped underneath there. And a lot of times that ice it'll drag it along the bottom. Okay, let's flip over to the next page. We also have another kind of moraine. It's called terminal moraine or end moraine, and this is rock that's trapped up in the front. Up in the front, the leading edge of the glacier is going to have what's called terminal moraine. When glaciers move through mountains, they are going to make a U-shaped valley. Okay, so if a glacier were to move through here and then eventually melt, what would be left behind is a U-shaped valley. Now, if you see mountains that have V-shaped valleys, those were not formed by glaciers, those were formed by streams. Okay, so a stream eroded valley is a V-shaped, and a glacier eroded valley is a U-shaped. I've got some examples of U-shaped valleys. Very cool. And then what I have on the bottom is something called glacial till. These are sediments that were deposited by a glacier. They are of all different sizes. They are not sorted. They are all random. There are some small pieces, and there are some pieces that are so big you would have a hard time even picking them up. But that is called glacial till. And all that is when the glacier starts to melt, it starts to drop anything that it was carrying, and it just drops it wherever it is. Okay, over on the next page, we got mostly pictures, things to look at here. We've got a picture of North America, and this is what it looked like about 10,000 years ago. We had this whole area here was a glacier. So northern United States, all of Canada was covered by a glacier. We have evidence of at least 4 major ice ages that have happened in the past 2 million years. The time in between the glaciers we call the interglacial period, which is what we are in right now because we don't have a big continental glacier there at the moment. But the most recent one was about 11,000 to 16,000 years ago, which is not that long ago. And if you look at this map of the United States, what this is showing you is that where all that red is, we have evidence of glacial till. So we have evidence of rock that has just been dropped. It's not sorted. It's of all different sizes. It's of kinds of rocks that are actually come from Canada. Glaciers picked up Canadian rocks and brought them over to the United States and dropped them as they melt. That's how we know that that whole area was covered with glaciers, because of the rocks that we find. And on my last page of notes, it is simply a diagram to label. The first thing on the diagram is actually not something I've defined in the notes yet. So this is going to be a new word. So number 1 is here, and it looks like a little hill. And number 1 is called a came. It's actually a cone-shaped hill made of sediment that was carried to the edge of the glacier by melt water. So melt water would be as the glacier is melting and water kind of flows off of it, some of that water will carry sediment away and it will maybe form a came. Now in this picture, this might be confusing as I'm looking at it here, but this is the ice. This piece right here is the ice. This is the glacier. And we're going to assume that the edge of the glacier at one point was way over here. And then as time goes on, the glacier is receding. It's moving away. So it's been melting, 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 melting. And then all of these things here are things that have been left behind from this melting glacier. Okay. Number 2 on the list is also something that I haven't talked about yet. It's called a drumlin. And a drumlin is an oval-shaped hill of glacial moraines. If you've ever been over to Mendon Ponds Park, there are a couple of good drumlins over there. Used to take students on a field trip over there to go see those. But they have some drumlins over in Mendon Ponds Park. And actually, Mendon Ponds themselves are lakes that were formed from glaciers. I have something here called an erratic, which is number 3. An erratic is a large, random boulder rock that doesn't look like it belongs there. And it looks like something that's very out of place. We have lots of erratics up in the Adirondack Mountains. If you've ever gone hiking up there and you've seen a really large boulder, now not like a cave or not a rock that makes up the mountain, but just a random huge boulder that isn't connected to any of the mountain, that would be considered an erratic, and that is a rock that was dropped by glaciers. So yes, glaciers were on the tops. They were all through the Adirondack Mountains. There's a lot of rocks up there that were brought over from Canada by glaciers. Number 4 would be a kettle lake. Excuse me. A lake. This is a lake formed when a piece of the glacier actually dropped off and it melted and formed a puddle. And that is what a kettle lake is, and that's what Mendon Ponds is. Number 5, we have a braided stream. So it's called braided because it looks like a braid. It has many pieces to it. And this is a stream that's been divided into different paths, but they all interconnect. So they all cross each other and form a system of channels. Number 6 is pointing to this whole area here. It's not really, looks like nothing. And this is called the outwash plain. And this is where layers of sediment have been deposited by the water from the glacier. So when water runs off of the glacier, it will pick up the smaller pieces and it will move those smaller sediments and it will deposit them out into layers. We've talked about terminal moraine before. We've talked about ground moraine before. Remember, those are rocks that are carried by the glacier, but they are going to be found in different locations. And then the last 2 things I've got here, one is called an esker, which is number 9 in the diagram. So I'm going to move that back up here. This is an esker right here. And an esker is a hill of deposits that formed from when a stream was flowing in a tunnel under the glacier. And then probably the most important thing we need to know about glaciers is that how do we know a glacier was in an area? And these give us really good evidence. So if there are striations on the rock, which just means scratches, those scratches are evidence that a glacier was there. Glaciers move with severe force, so if they're moving through an area, they are scraping up and making a mess wherever they go. So seeing these striations left behind is evidence that glaciers were here. And the striations are going to give you a hint as to the direction that the ice moved as well. Okay, that is everything that you need to know about glaciers. Tomorrow we're going to have a Edpuzzle on glaciers, and you're welcome to use all of the notes that I gave you today to help you. Oh, and hey, may the 4th be with you. See you soon.